Welcome to Tuesday, everyone. Thank you for showing up for your learning again. And welcome to Grade 10 Academic Math. We are day 3 and 4 today of Unit 1, which is our unit on linear systems. Our main topic for today is solving linear systems by substitution. All right? Now, I just want to take you on a quick tour of some things in the D2L to help you organize yourself for today. In the D2L, you're going to find under content, you're going to find Unit 1 linear systems. You're going to find a checklist here. It tells you the topics that we're doing by day. I've been asked, hey, Mr. Jennings, it would be useful if you could hyperlink some videos here to teach us these topics. So I'll do that as well. That's coming. And your homework for today is here next to Tuesday, the 21st. That's today. Here's the homework questions for the first topic and the homework questions for the second topic. And you'll also find an assignment in Delta Math for you today. Definitely prioritize the Delta Math assignment, but these questions in the textbook can also help you practice as well. Prioritize Delta Math and then do textbook. Or do textbook and then when you're ready, finish up with Delta Math when you're ready. All right, any questions, definitely email me or definitely find me with your questions tomorrow. I'm not in the building today, but I am with you in spirit and I'm with you electronically. Let's go to the lesson. So let's start by reviewing what we looked at yesterday. We learned to solve systems of equations graphically, and that's pretty cool. That means we can find the intersection between two lines and find the single x value and the single y value that's going to make those true. So let's see how we would do that here. I'm going to graph these in the quickest way I know how. First, I could convert them to y equals mx plus b, and then I could put them on graph paper. But I didn't bring any graph paper home, but I have decimals. Oh, there, that is that line. So I can tell that it has a b value of -3, and its slope, it goes over 2 and up 1. So it has a slope of 1/2. So this is also equal to y is equal to 1 over 2x minus 3. See, same line. Okay, I just converted that line to y equals mx plus b. All right, now let's graph the second line. The second line was 3x plus y equals 11. Copy, paste. Oh, okay, and now here's my solution. All right, now what does that mean, the point 4, -1? Well, it means that 4 as the x and -1 as the y is the only point in this infinite sea of points. It is the only point that is on both the green line and the red line. Okay, 4, -1. So if I put in those values for x and y, they satisfy this equation. They also satisfy that equation. And it's the only possible values of x and y that will do that. This is how we would do a graphical solution. Okay, and remember what we're looking for. We're looking for one point. Now, let's take a look at another way we can find our answers. All right, we don't always have to use Desmos. We don't always have to use graph paper. We can do some algebra from time to time. So the answer was, 4, -1. Thank you, PowerPoint. Now, here we go. Solving linear systems by substitution. By the end of today, you want to solve systems of two linear equations involving two variables using the technique of substitution. If you can do this by the end of the day, you are on track. Let's keep going. So, and we have this on your handout. At the point of intersection, the x coordinates and the y coordinates for both graphs are equal. So x will equal x, y will equal y. And we can use that principle to solve linear systems by replacing one variable with an expression from the other equation. We're gonna rearrange one equation and stick that equation into the other equation, and it's gonna solve. So let's see how we do that. Okay, let's see an example here. Now you have this on your handout. First thing it asks us to do is label these equations. So join me on the handout, if you will. Here we go. Dun, 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 dun. I brought the document camera home, so we can do this together over here. So now let's put me over there. All right, so let's do this now. You can follow along on your sheet as well. The first thing that I want to do is I want to solve one of these equations for one of the variables. All right. Now I can solve any one that I want, but I see that solving for this x would be rather easy, or solving for this y would be rather easy. So let's choose solving for this y. we can do either way. There's different roads to a solution here. So I'm going to rewrite that equation, and I'm going to label them too. That was important to remember. This is equation number 2. This is equation number 1. So here's equation number 2. 3x plus y equals 11. Okay, so now rearrange so that I've solved for one of these variables. That means isolate that variable. And I see that I could do that by simply subtracting 3x from both sides. When I subtract 3x from both sides of the equation, I've honored the equal sign. I bring my y down. This is 0, so I don't write anything. Y is equal to negative 3x plus 11. Okay, I'm going to circle it because that's something that's important. I've just found that, and I'm going to use that next. Now, I've rearranged equation number 2. So now I'm ready to substitute into equation number 1. If you substitute this into equation number 2, you'll get something like 11 equals 11, and you won't be any closer to a solution. But if you substitute it into number 1, you'll get a value for x, and we're going to see that happen now. So now I'm going to substitute this into number 1. So I'm going to rewrite equation number 1. X minus 2y is equal to 6. But I know that at the point of intersection, y also equals negative 3x plus 11. So substitute that in. Substitute into brackets, please. X minus 2 bracket negative 3x plus 11 equals 6. Okay? So now I've substituted into a bracket. I now have to expand this bracket to now solve for x. But the important thing to note, I now have one equation, one variable. I can solve for that. Here I had one equation, two variables. Here I had one equation, two variables. I can't solve. There's an infinite number of solutions. But here, one solution I can solve. So let's do it. Now, first thing I'm going to do is expand this 2 into the bracket. I see that I have a binomial there, two terms linked by addition or subtraction. So I have to expand that in. Negative 2 times negative 3 is 6. So I have x plus 6x. Negative 2 times positive 11, negative 22, okay, is equal to 6. So all I did was I expanded that, and it gave me this. And then I bring this x down, and then I'm going to collect my like terms. But I'm also going to move all of my numbers to one side and all of the variables to another side. That way I can solve for those variables. So let's advance this up here a little bit, and let's do that. Okay, so x plus 6x. An apple plus 6 apples is 7 apples. Okay, 22. I'm actually going to add 22 to both sides to give me 7x is equal to 28. 6 plus 22 is 28. Now, I see that I have 7 apples here, but I want to know what 1 apple is. 7x, I want to know 1x. So I'm going to divide by 7. Another way of saying that is 7 multiplied by x is equal to 28. So x has to be equal to 4. All right, 28 divided by 7, 4. So write that down. X is equal to 4. Circle that. That is half of your answer. The other half of your answer, you'll remember, is going to be a y coordinate. So let's go ahead and we'll work over here. What we're going to do now is substitute x into this equation or that equation. And then we can solve. We can choose either one. I think the second one is going to be a little easier. So let's do that. And to be honest, this one that's already rearranged is going to be the easiest. So let's use that one. Okay, so now I'm going to take that and I'm going to sub x equals 4 into equation number 2. Okay, this is just a rearranged equation number 2. Let's do that. Okay, so I have y is equal to negative 3 multiplied by 4, because that was x, but now it is 4, plus 11. Negative 3 times 4 is negative 12. Y is equal to negative 12 plus 11. If it was negative 12 yesterday, but today it's quite a lot warmer, it's 11 degrees warmer, it's still negative 1 degrees. It's still below 0. So y equals negative 1. Circle that. That's the other half of your answer. Now, put your whole answer together like this. Therefore, the point of intersection is 4, negative 1. Write it as a point like that. Put a period at the end of your sentence. Okay? And so that's That's a complete solution. All right, let me pause for a second and have a little chat with my daughter. She's also doing some math, apparently. We are back. Now, let's use the PowerPoint to check our answer. Normally, you could use Desmos and very quickly check your answer, but I know that this PowerPoint also solves this system. So let's go forward. Boop. Rearrange one thing for x. So they chose to rearrange the first equation for x. And we called that a new equation, called equation 3. I call it just rearrange 1. It's the same thing. Okay, and then they substitute that in. You can pause the video if you want to see their solution, but they solved for y. Okay, they solved and found that -1 was y. We solved and found that 4 was x. We chose a different road to the solution. Pause and take a look and see if you can follow if you want. But then let's take a look. Now they subbed back in. They subbed in their y, and then they calculated x. Therefore, the solution is 4, -1. My statement was a little different. I used the 3 balls to represent therefore, 3 balls in a triangle. And then I said, therefore, the point of intersection was 4, -1. It's the same thing. The intersection means the solution to that system of linear equations. So that's how you do it. Now let's take a look at some more examples. Oh yeah, we can check our work as well. So here they are checking their work. And this is how you will check on a test to make sure that you have the right answer. You check by substituting the point you found into both equations. Here we have x minus 2y equals 6. So you see they substituted in 4 for x and -1 for y. And when they worked out 6 equals 6, that tells you, yeah, that's good. That is a solution to that line. You found that point is on that line. Then you check the other line, and you find, yes, indeed, 11 does equal 11. That indicates that that point is also on the other line. Yeah, so this is an algebraic road to a solution. Now let's take a look at 3 more examples. And you're going to work along with me, and then you're going to work on the homework questions. And when you get questions inside the homework questions, you're going to email me and ask me the question as best you can. And this is what it sounds like. Mr. Jennings, I can't do number 2 yet. I've tried to solve for x, but it tells me that when I substitute it back in, I'm just not getting the right answer, and I feel like I made a mistake. Could you give me some information on number 2? And then I know exactly what to help you with. Okay, so just give me some details on your question and what you're looking to do. Screenshots are great for Delta Math as well. Okay, let's go. We're going to do some more examples. So we have these examples on your handout too. We're going to do each one. So my first step, label my equations. I like A and B. Okay, I need to choose one to rearrange. Let's rearrange this one for y. All right, so I'm going to take equation A and rewrite it. 2x minus y equals 13. Now, I want y alone, and I would like it to be positive. So I'm going to add y to both sides. Now I got y over there. Problem is it's got a 13 with it. Let's subtract 13 from both sides. All right, everyone, we're not the only ones that find this really interesting. Also, my daughter finds this stuff very interesting. So she's going to work ahead by 9 grades and get a head start. So here we go. So we decided to subtract 13 from both sides and add y to both sides. Let's see why I chose to do that. Now, you might do this in 2 steps, and that's okay. I do it in 1 step. Big deal. All right, so I have 2x minus 13 minus y plus y. So the minus y plus y is 0. But on this side, what I have is 2x minus 13. So let's write that down. 2x minus 13 equals 13 minus 13 is 0. Plus y is y. So I have 2x minus 13 is equal to y. Hooray, circle that. That is what y is at the point of intersection, because the intersection is on this line. That's my A rearranged. Now let's substitute that into B. So I'm going to start by copying out B. Okay, so let's do that. We're going to copy here. 4x plus 3y equals 1. Now substitute this in for y. All right. So I'm going to have 4x plus 3, substitute into brackets, 2x minus 13 equals 1. All right, now solve for x. Notice we have one equation, one variable. We can solve it. So I have to expand this into the brackets. I like showing you that I'm going to expand that and that. That's positive 3. So I have 4x plus 6x. Every time I say that, I think success. Plus 3 times negative 13 is negative 39. Use your calculators if you need to, but you can also start doing these things in your head. Challenge yourself to do it in your head, and then check with your calculator is a fine way to do it. Now I see that I'm going to have 10x over there, but I want to add 39 to both sides. Why did you do it in that direction, Mr. Jennings? Why didn't you subtract 1 from both sides to move that 1 to the other side? Then I end up with all my numbers and all my variables on the same side, and I want to get them separated. I want to get them on the opposite sides of the equal sign. So now let's rewrite another line. 4x plus 6x is 10x equals 1 plus 39 is 40. 10x equals 40. X must be 4. All right. If you're confused, then you divide by the coefficient. 40 divided by 10 gives me 4. So x is equal to 4. Circle it. That's half your answer. Now, you're going to substitute that in to either equation, whichever one you think is the easiest to work with. Honestly, I think this one is easiest to work with because it's just going to directly give me my y. So let's do that. I'm going to take x is equal to 4. I'm going to just bring that up there, and I'm going to say sub x equals 4 into equation A. And this is equation A rewritten. So let's do that. All right, so I have 2 times 4 minus 13 equals y. Okay, so 2 times 4 is 8. 8 minus 13 is negative 5. You want me to write it all out? Sure. 8 minus 13 equals y. 8 minus 13 is negative 5 equals y. Circle it, the other half of your answer. Now, write a therefore statement. Therefore, the solution is 4, negative 5. What's so funny, Missy?
Does he say that funny?
Oh, I see. And then you can check your answer. You can go ahead and check my answer. See if I made a mistake. If I did, leave a comment, okay? Because this is going to be a YouTube video. And don't forget to smash like and subscribe. You don't have to do that, okay? Because I'm not promoting myself and my YouTube channel. But, I would check this by substituting it in there and there to see if it's true. 4, negative 5. 2 times 4 is 8. Negative 5 is plus 5. 8 plus 5 is 13. Someone who created this loved Fibonacci numbers as much as I do. Down here, 4x is 16 plus 3 times y is negative 15 is equal to 1. It works. Okay, I'll check my answer. I will get perfect on the test. Now, we have 2 more to do here. I'm actually just going to do this one because I don't want this video to be 15 bajillion minutes. And I want to get to one application question, okay? So we're going to do this one. If you want, you can post your solutions to this in the comments or send me an email or tell me tomorrow because I should be at school tomorrow because this one I think is going to be at school tomorrow.
Yeah.
Yeah, all right. So let's do this. Okay, we label our equations, A and B. If you want to call them Q and R or Larry and David, that is fine. You label your equations, though, just label them. All right, so first thing I want to do is choose one to solve for. By far the easiest is solving this one for y. I just add y to both sides. Now I see that immediately. Maybe you don't see that immediately. You could do this with any variable. Let's do one that's a little more challenging. I'm going to isolate this one for first for x. I'm going to isolate for x here. So I'm going to rewrite b over here. B is equal to 6x, success, plus 3y equals 36. All right, now, for some reason I choose to solve for x. I'm going to get fractions, and I'm not going to freak out. All right, this is what it's going to look like. I'm going to subtract 3y from both sides. Someone moved my pens. Give me my red pen, please. Thank you. Okay, so I'm going to subtract 3y from both sides. All right, that pen should stay there. I should know where it is. 6x equals negative 3y plus 36. All right, and don't freak out, people. We're going to get fractions at this stage. Divide by 6. Notice I have to divide the whole side of that equation by 6. Okay, so that gives me x is equal to negative 3 over 6. Negative 3 over 6 is negative 1 over 2. Okay? So that's negative 1/2 y plus 36 over 6 is 6. Okay, cool. Circle it. We're going to use that. All right? Now I know what x is at the point of intersection. That was my equation B rearranged, so I'm going to substitute that into equation A. All right? Why did I start in the middle of the page? I'm going to go over here now. So ignore this. I'm not doing that right now. I'm doing that one. Okay, so let's do it. So I'm going to rewrite equation A is 5x minus 7 minus 2 equals 0. I know that x is that, so let's substitute that in. 5 multiplied by negative 1/2 y plus 6 minus y minus 2 equals 0. One variable, one equation, solvable. Fractions considered. Fraction is just a number. So just do your fractions operations. Treat it like any other number. Okay, let's expand this in. I have to multiply this 5 by that and by this because there's two terms in there. So I have 5 times 1, negative 1 over 2. That gives me negative 5 over 2y. 6 times 5 is plus 30. Plus, this is not negative, this is plus. They're both positive numbers, okay? Minus y, so it's minus 1y. How about we write that as minus 2 over 2y? We'll create our common denominator right away. 2 over 2y. We're still subtracting that. Okay? Minus 2 equals 0. Okay, now collect all my like terms, collect all my y's. I have negative 5 over 2y minus 2 over 2y. So I have this common denominator, so I just add the tops. So I add negative 5 to negative 2. Hold on one more. I'll show you something very, very interesting. But let me finish first. A negative 5 over negative 2. You keep going. You're doing good work. Negative 5 over negative 2 is negative 7. Okay, so I have negative 7y's. Negative 7 over 2y. Plus 30 minus 2 is plus 28 equals 0. All right? Now, subtract 28 from both sides. Gives me negative 7 over 2y equals negative 28. Now remember yesterday where I said when you're multiplying by a fraction here, you can multiply by the reciprocal and make it 1. So I'm going to multiply both sides of the equation by 2 over 7. Actually, negative 2 over 7. Okay, so multiply by negative 2 over 7. Okay, cool. All right. So what is that? Well, the reason why I did that is this is 1. Because the negative 2 cancels the 2, the 7 cancels the 7, negative cancels the negative. That's 1. That's why I chose to multiply by the reciprocal. So that leaves me with y equals on that side, and that's just going to give me a number over here. Negative 28 times negative 2 will give me positive 56. 56 divided by 7 is going to give me 8. So this is 8. There. Set y is 8. I found it. I'm done. No, I'm not done. I've done half of the work. I need to now find x. So I found my y. Now I need to find x. Okay. So I'm going to substitute that into either a or b. Let's choose the unmodified b for fun, because that's super fun. Okay, 6x plus 3 multiplied by y equals 36. Sub y equals 8. 6x plus 3 multiplied by 8 is equal to 36. 6 times x plus 3 times 8 is 24 equals 36. Subtract 24 from both sides. Leaves me x is equal to 2. Okay, you need to write all these steps out? Okay, fine. 6x equals 12. X equals 2. Okay, I divided 12 by 6. Okay, and I got x is equal to 2. And now I'm done. Okay, now I can do my therefore statement. Therefore, 2, 8 is the solution. Or the point of intersection is 2, 8 would also be a fine way to say that. Okay, and then you could check this if you doubt my work. If I've made a mistake, leave a comment. All right, now let's keep going. We have one example of an application question to look at. But before we do, I have something to share with you. Get over here, honey. Look what my daughter's been doing. She's a grade 1 and she's copying the work. She's just copying what's on there. Honey, you've done a wonderful job. You're learning all about X and Y in math. Now you know that not all numbers are numbers. Some numbers are letters. And they'll drive you nuts when you're in grade 9. And by the time you're in grade 10, you'll be like, oh yeah, I got this. Maybe you're not there yet, but hopefully you get there this term. Let's go on with an example. Okay, this one. The admission fee at a small fair is $1.50 for children and $4 for adults. On a certain day, 2,200 people enter and $5,050 is collected. So we want to know how many children and how many adults came. We don't know the numbers of how many children and how many adults came. So we better have some let statements. I'm going to use X and Y. I could use C and A. I'm going to use X and Y. Okay. Let X equal the number of children. Super important step. Because you want to know what your letters represent. If you don't know what your letters represent, you'll be confused. I would be confused. I don't want to work confused. I want to work from a foundation of confidence. So let Y equal the number of adults. Yeah. Now, what are some things that we know? We know that 2,200 people entered the fair. So X plus Y equals 2,200. All right. So here's equation 1. X, which is the number of children, plus Y, which is the number of adults, must total to 2,200. Okay, that's one of my equations. But now I also know how much money was collected. Now notice, this is 2 variables, infinite number of solutions, basically. We can't have an infinite number because we can't have fractions of a person. That's too gruesome to imagine. I do not want you imagining fractions of people. But here, if we have there could be 2,200 children and 0 adults. There could be 2,000, and that would be chaos. Okay, there could be 2,200 adults and 0 children, and that would be boring. Okay, so there's going to be so many solutions in between. One equation, 2 variables, not solvable is what I'm pointing out. Next, I need another equation so I can solve this. And I'm going to get that by the amount of money collected. It's $5,050. And how did they make that money? Well, every child who came paid $150. So I'm going to put 1.5x plus, and then y was $4. Was 4y. So this, every adult who came paid $4 and then created that amount of money. Every child that came paid that and then gave me that amount of money. Again, 2 variables, 1 equation, can't solve. But now I have 2 equations, 2 variables, I can solve it because I can create 1 equation, 1 variable. Now, we're going to go ahead and solve this for x. So I have x plus y equals 2,200. Subtract y from both sides. I could also subtract x and solve for y. Okay, and the x equals negative y plus 2,200. Circle it, I'm going to use that. Substitute that into number 2 here, okay? So I know what x is. So 1.5 multiplied by negative y plus 2,200 plus 4y equals 5,050. Oh, I'm way down at the bottom of my camera. So there we go. Now this is the new equation I got by taking my value x that I worked out from the first equation, and I substitute that into the opposite equation, the second equation. Put it in for x. See how I substitute it into brackets. Now I'm going to expand that out by multiplying by that term and that term. So I'll have negative 1.5y plus 2,200 times 1.5 is 3,300. I should factor the numbers in my head and work it out. It's very fast if you just do these things in your head first before going to your calculator. You'll develop the skill. Plus 4y equals 50. Okay? Now, I want to get my y's all alone on one side of the equation, so I'm going to gather them. Negative 1.5y plus 4y is going to give me 2.5y. But I want to subtract 3,300 from both sides as well. For some reason, I can't do that in my head right now. I need to just do it on the calculator because I'm really distracted. Here, negative 1.5 plus 4 is 2.5. Y is equal to 5050 minus 3300. That's 1750. Okay, and I'm quite confident in that. Now, divide both sides by the coefficient, 2.5. Now, I should probably be able to do that in my head, but I don't want to have you watch me stare up into the left corner of my brain for a little while. I'm just gonna calculator it, okay? Sometimes you just use calculator, all right? So here I go. 1750, please don't be a fraction. Divide by 2.5 equals 700. Okay, good. All right, there we go. So y is equal to 700. What did we just find? Well, we're going to circle it because that's part of our answer. Y is equal to 700. All right, what did we find? We found that the number of adults who entered were 700 adults. That told me 1,500 children came. How did I do that so fast? Well, I used equation number 1 in my head. And I'll show you what it looks like. Over here, equation number 1. I'm going to write it out again. X plus y equals 2,200. Substitute 700 in for x. X plus 700, it's for y, I'm sorry, is equal to 2,200. And then I'm going to subtract 700 from both sides. Is equal to x is equal to 1,500. Circle. Now, I don't write a therefore statement and say, therefore, the point of intersection is 1,500, 700. I say, therefore, 1,500 children attended. 1,500 children and starts with an A and D. 700 adults attended. Your homework should be on the board, and these are all the examples that you need. And this is how you use the algebra to find out where two lines touch. This is one example of how that might show up in an applications question. If you have questions, email them to me. Put a note in your book and ask me tomorrow. Hopefully I'm there. Or see if you can ask your classmates and solve that. What's up, dear? Oh, you wrote down 1.5 plus 4y is equal to 5070. Okay, that's interesting. I don't know where those numbers came from. Bye for now, everyone. Thank you very much for showing up for your learning. Even though I couldn't show up physically, I'm certainly there in spirit, and I'm there digitally. Bye for now.